Welcome to Physics with Mr. Peacock. Today we are going to be talking about solving differential equations using separation of variables. Specifically, we're talking about drag force. I'm here on question 1 from our notes pack where we have a box and it's sliding with some initial velocity and it's experiencing a drag force of negative kV. And we are trying to find what is an equation for the velocity as a function of time. The very first thing I'm going to do is draw my free body diagram. So I know that I have gravity coming down and normal coming up, and I know that there's no acceleration in the y direction, so those are going to be equal. And then I have my drag force, negative kV. Even though I have initial velocity, there is no force going in the positive x direction. That's a velocity that our object started with, but it's not a force, so it does not go on our free body diagram. Now that we have our diagram, we're going to write out our equation for Newton's second law, F equals ma. And then we're going to expand that. We're going to say that our net force, we're going to call this the force in the x direction. Our net force is negative kV. And that is equal to mass times acceleration. And I know that if I write acceleration as a differential, it would be the derivative of velocity with respect to time. A equals dv over dt. So I'm going to put that in. Negative kV equals m dv dt. This is what we would call a differential equation because we include the derivative in the equation. And now I'm going to use a process called separation of variables. I'm going to get everything that is a v over on one side and everything that is not v over on the other. So the first thing I'm going to do is I'm going to multiply this dt over to the other side. Negative kV dt equals m dv. The problem now is that I still have a velocity over here, and I have something that's not velocity over here. So I've got to divide both sides by v and m. V and m. And that's going to give me negative k over m dt equals 1 over v dv. So all I did was divide both sides by m. My m's cancel out. And then divide both sides by v. My v's cancel out, and I'm left with this. So now I have everything that is a velocity on one side, everything that's not a velocity on the other. And now I'm going to take the antiderivative. I'm taking the antiderivative on the left side with respect to time. That's the dt. On the right side, I'm taking the antiderivative with respect to velocity, dv. So this is going to come out to be negative k m t plus, we'll call it c1. On the other side, we talked about in class, one of our math facts is that the antiderivative of 1 over the velocity is the natural log of the velocity, plus we'll call it constant 2. And we've talked before how when we have some unknown constant and some unknown constant, we can combine those to the other side and just make this plus some other unknown constant. So now we have negative k over m times time equals the natural log of velocity plus some constant. And now we have to solve for our constant. So when time is equal to 0, we know the velocity is v naught. That was given in the problem. So we're going to plug that in. When time is equal to 0, everything on the left side of the equation will be 0. And when we plug in v naught, we get this. Now this is a constant. It's the natural log of a constant. It's no longer a variable. It's the actual value that we had. So then we know that if we solve for C3, C3 is going to equal negative the natural log of the initial velocity, because that would give us 0. So if we rewrite our equation, it's now negative k over mt equals the natural log of our velocity minus the natural log of our initial velocity. And then I'm solving for velocity, so I've got to get velocity by itself, so I'm going to take this, I'm going to add it to the other side. So then I'll have the natural log of the initial velocity minus k over m times time equals the natural log of velocity. And what I'm actually going to do here is I'm going to make this plus negative, just to kind of keep it straight with the math rules that we talked about in class. So now what I need to do is I need to get v by itself. So I have to do the inverse of the natural log, which means what I'm going to do in this equation is I'm going to take each side and make it the exponent of e. So when I take e raised to the power of the natural log of v, that's going to give me v. When I take e raised to the power of the natural log of the initial velocity plus the power of negative km over t, remember that becomes multiplication. So e to the natural log of v naught multiplied by e raised to the power of negative km t. And then the last thing I know is that this e and this natural log will cancel out. So the initial velocity multiplied by e to the negative km t is equal to the velocity as a function of time. And we should find that when we graph this, this matches the graphs that we talked about in class. The end.